Hello friends. So today I'm going to explain the lead code problem number 2872, maximum number of k divisible components. This is today's lead code POTD. Okay, problem of the day. So this is related to tree and graph concept. So let's understand what the question says. Let's read it. There is an undirected tree with n nodes. Okay, means there is a tree and there are n nodes. Okay, labeled from 0 to n minus means it is labeled to 0 to n minus n. You are given the integer n and a 2D integer array edges. Okay, आपको एक इंटीजर n दिया गया है एंड 2D इंटीजर एरे एजेस का दिया गया है. ओके, ऑफ लेंथ n minus 1. ओके, because there are nodes from 0 to n minus, that's why its edges length is n minus 1, where edges of ai comma vi means there is an 2D array in which edges I is represent ai to vi means from ai to vi there is an undirected edge means we can go from vi to ai or ai to vi. Okay, indicate that there is an edge between nodes ai and vi. Okay, you are also given zero indexed integer array values of length n. Okay, where values I is the value associated with the ith node and an integer k. Okay, means the question says that you also have to give in values array which is represent that the node I value in the values I. Okay, and also given an integer k. Okay, let's understand further. A valid split of the tree is obtained by removing any set of edges, possibly empty. Okay, from the tree such that the resulting components all have values that is divisible by k, where where the value of connected component is the sum of the value of the nodes. Okay, me the question says that आपको एक ट्री दिया गया है एंड इस ट्री में आपको एक वैलिड स्प्लिट करना है. अब वो वैलिड स्प्लिट वो होगा उसमें जो कंपोनेंट्स जो हमने निकाला होगा कंपोनेंट का, उस कंपोनेंट्स में जो सारे नोड्स हैं उनके सम नोड्स के वैल्यूज का सम जो होगा वो मस्ट बी डिविजिबल बाय k. Okay, so that is valid split and that is valid component of we have, and we have to return the maximum number of components. Means how we can return the maximum number of components? If there is let's understand using this example. If there is let's understand if there is in 5 edges. Okay, sorry, 5 nodes, so the maximum number of components we can split is 5. Why 5? We can split all the edges, we can break all the edges if all the nodes have values is divisible by k, then it is possible. Else we have to sum up to sum up to the up to we didn't get the सम विच इज़ नॉट डिविजिबल बाय के. ओके, हम जब तक ऐड करते जाएंगे सम को, जब तक हमें एक ऐसा कंपोनेंट नहीं मिल जाता जो कि डिविजिबल बाय के ना हो जाए. ओके, सो लेट्स अंडरस्टैंड दिस here. Okay, let's see here. There is let's understand from the leaf node, that is leaf node. Okay, so if because current node we cannot break it, because if we split it here then we also handle these nodes also. So we move from root node. Okay, let's understand from root node. We go from the root node to the leaf node. So let's say this is root node. Okay, so from here to we go 3. Okay, now 3 is the leaf node. So we asked to 3 node that you have a value something that let understand. Okay, understand क्या इसमें दी गई है वैल्यू नोड 3 की. Okay, okay, node 3 have value 4. Okay, node 3 have value 4. Okay, now we ask to node 3 that you have that value which is divisible by k or not. If it is not divisible by k, then it देन इट फॉरवर्ड टू द रूट नोड दैट, ये बोलेगा रूट नोड से कि आप मुझे भी ऐड कर लो, क्योंकि 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 ये मैं अकेला एक कंपोनेंट वैलिड कंपोनेंट नहीं बना पाऊंगा, बिकॉज वैलिड कंपोनेंट के लिए इसको डिविजिबल होना पड़ेगा के से, इसके सम को, इसके वैल्यू को डिविजिबल होना पड़ेगा के से, बट इट कैन नॉट बी पॉसिबल। सो ये कहेगा अपने रूट नोड से कि आप मुझे भी अपने साथ ऐड कर लो, एक कंपोनेंट बना लो, क्योंकि मैं अकेला नहीं बना पाऊंगा। तो ये ऊपर सम ऐड रिटर्न कर देगा, ओके, अपना वैल्यू। ओके, नाउ दिस वन इज check from this another child, okay, now it asks to 2, but 2 is not a leaf node. Now then again 2 is asked to 4. Now this is 4 leaf node, okay, this is leaf node, okay, this is leaf node, okay. Now 4. Now we look at 4. Now 4 node have the value 4, okay, you can see from their example. 4 have 0 1 2 3 4 4 node 4 have 4 value, okay. Now we again check that 4 is divisible by k. Now here k is 6, okay. 4 is divisible by k or not? No, this is not divisible by k. So ये क्या कहेगा कि आप मुझे भी अपने साथ ऐड कर लो, बिकॉज मैं अकेला नहीं बना पाऊंगा। तो ये अपना जो सम होगा, अपनी जो सम की वैल्यू होगा वो ऊपर रिटर्न कर देगा, किसको, रूट नोड को, अपने रूट नोड को रिटर्न कर देगा, ठीक है। now this two root node is asked to another child, ये भी लीफ नोड है इसका। फिर ये पूछेगा कि आप क्या मुझे, sorry this node have value 1, so क्या 1 is divisible by k? divisible by k means divisible by 6? no. so ये क्या अपने रूट से बोलेगा कि आप मुझे भी ऐड कर लो। so यहाँ पर हम लोगों का सम कितना जाएगा, यहाँ पर समझ जाएगा this 4 and this plus 1, okay, so यहाँ पे क्या होगा 4 plus 1 that is 5 and 2 का अपना अपना भी वैल्यू है। so कितनी है 2 की अपनी वैल्यू कितनी है 1, so यहाँ पे क्या हो जाएगा 4 plus 1 that is 4 plus 1 plus 1 that is 6, okay. Now when these both nodes return the value to this node, now it sums to 6 and 6 is divisible by 6, so we get a new component, that is valid component, that is this component, okay. so here we can see, look here, that is this component. so now this is divisible by this whole sum is divisible by k, and this is valid component, okay. so now this is, we get the valid component and we have to return the maximum valid component. so we don't further don't further add another sum to it, to this component, because we got this component which is divisible by k. so we return to it, we return further sum equals to 0, because it make the on component. now ये अपने साथ और कोई कंपोनेंट को ऐड, और कोई नोड को ऐड नहीं करना चाहेगा, बिकॉज ये ऑलरेडी अब एक वैलिड कंपोनेंट बन चुका है, एक डिविजिबल एक ऐसा इसमें सम बन चुका है, सम बन चुका है जो कि डिविजिबल हो चुका है, किससे, के से, ओके। सो नाउ वी रिटर्न टू इट सम इक्वल्स टू 0। now from here it returns sum equals to 0, from here it returns the to its 3 की वैल्यू, 3 की वैल्यू क्या थी हमारी 4, क्योंकि 4 is not divided by 6, so it return 4, from here 0 and 1 have the value 8, okay। now 8 plus 0, 0 from left and 4 from right, okay, so total value is 12. now this component is also divisible by k, that is 6, 12 is divisible by 6, so this is also a valid component, this is also valid. so there is a valid split, so there is total 2 components made, okay। so this is how this question approach works, okay। now let's move on its code, its approach, okay। I write it here, okay। firstly what we have to do, we have to make the list array, sorry, adjacency list, okay, which stores ages from 0 to 1, from 1 means from 0 से हम कहाँ जा सकते हैं, ठीक है, from let's here from 0 we only go to 2. From 1 we only go to 2 and 3. From 4 we only go to 2. Okay, like this. Okay, from here I make the adjacency list. Okay, this is my adjacency list. Okay, this is my adjacency list. Now I call the dfs function. Okay, dfs. Okay, so here my dfs. Okay, first understand. First I take the long sum equals to 0. Okay, why sum equals to 0? In starting I take the sum equals to 0. From here let's see, this is root node. From here I pass the sum equals to 0. Okay, now I check. Now I go up to लीफ नोड. जब तक हमें लीफ नोड नहीं मिला तब तक हम इसके डीएफएस को कॉल करते रहेंगे. देखिए यहाँ पे डीएफएस को कॉल करते रहेंगे. फर्स्ट हम लीफ यहाँ पे 1 पे गए, हमें लीफ नोड नहीं मिला. फिर हम 3 पे गए, लीफ नोड, वी गॉट द लीफ नोड, वी गॉट द लीफ नोड. व्हेन वी रीच द लीफ नोड देन वी चेक फॉर सम. सो हम जब लीफ नोड पे पहुंच जाएंगे तो हम पहले सम को ऐड करेंगे, सम वैल्यू को ऐड करेंगे सम में. नाउ वी चेक फॉर सम. इफ sum modulo with k if equals to 0 means remainder comes out to be 0. If remainder comes out to be 0 means we understand this component or this particular node or this particular leaf sum is divisible by k. Sum is divisible by k. Okay, sum is divisible by k. So we add with component count means we increase component count. What? We increase component count, we increase component count, and we make the sum equals to 0, because we started and from here we started a new component, because one component we got where the sum is divided by k. So we have to start a new component. Okay, so that's why I make the sum equals to 0 and return the return sum. Okay, I hope you understand that how recursion works. Okay, because this is a recursion. Okay, this is not something, this is nothing but recursion. Okay, so let's run it. Okay, so all test cases are passed. Let's see, is it submit or not. Let's see. Okay, it's submitted. Okay, you can see. Okay, thank you and sorry for voice. Okay.